Okay, so thank you very much for having me here tonight. So tonight we are going to talk about the OWASP Top 10 2017. And just to make sure that you understand that we are talking about the OWASP, I came with a t-shirt and has the closing tag. So everything in line. Okay, a little bit about myself. I come from a software development background. So if you think that security is that scary thing, you're wrong. I was just like you, coding PHP, yes. And I moved security consultant at Veracode. Yeah, I was PHP shamed, like you probably know. But the thing is that because I dealt with PHP, and after you deal with PHP, you can do everything. So I was pretty good at this one. And then I was so good that the company got, got a little bit of courage, and they hired another PHP after me. So now there are two of us, so we kind of grow there a little bit. So I work as a consultant. I work with developers every single day. I also lead the OWASP Bristol chapter. We have meetings every 2 months. Our next meeting is on the 14th of June. If you fancy coming to that one, we promote the meetings on Meetup. So please sign up to Meetup and see you when come up to the next meeting. I'm also involved into OWASP, the AppSec EU conference. This is the largest conference on application security in Europe, and this year is in London, pretty close to us. So if you fancy going there, please have a look at the registration. The registration is open. The program is already up there. The trainings are. There's an awesome training with Mario in web attack, and few other ones that might be of interest to you. If you can't convince your company, then there is also the option to volunteer. So you can participate at the conference. If you volunteer your time to help out. I've did this one. It's not that awful as it sounds. If you're as a conference aide, then what you end up doing is sit in a room. You end up sitting in a room, but then you listen to all those talks in the room. So you don't. That's another nice trade-off. So coming back to the OWASP Top 10, I don't know if you are aware, but there was a little bit of change in the leadership, and the last version was actually released by Andrew van der Stok. He was asked to shepherd this project to the final release. Andrew is a well-known security professional, is also a board member, has been with us for some time. And his vision was that I'm going to bring together this list, which is a tester list. It's very good for the testers because it helps to assess the security state of an application, to bring it together with builders and defenders. There is no such a thing as OWASP Top 10 for defenders yet, but they are looking into it. There are a few changes that they've also decided to do. First of all was transparency. This version was handled on GitHub. Every issue was logged there, so everyone can see the progress, who has commented, what were the changes made. Also, they decided to do a new data call, so they asked the vendors to submit a new fresh of data. They wanted to get more out of the data. And another thing that they was like in the new set of items, to name them something that makes sense for more people. If you remember in the previous version, it was that missing function level access control, which was so difficult. So one of their purposes was to bring in line the naming of the items with the CWE. The CWE stands for the Common Weaknesses Enumeration. And another change is the orders the items are listed on. Again, Andrew van der Stok actually asked on Twitter how people would like the items to be ordered, and the options were as the existing order, like the previous one, the 2013, or by impact, or by likelihood, or by risk, which is a combination of two. Over 50% of the respondents choose the risk. And this is the new list as in combination with the previous one. There are two new entries in this one. Those new entries are based on an industry survey, where previously were a couple of people in a room trying to figure out what to put. This time it was a survey where industry peers submitted their recommendation, and this is how the two forward-looking issues have been added to the OWASP Top 10. These are insecure deserialization and insufficient logging and monitoring. There has been a new item added. This entry was based on data, so there was enough data. The XXE or XML external entity, there was enough data to support this entry. So I will go a little bit in detail to each of these. And we'll start with the first one, which is injection. Now, injection has been around for some time. In fact, the first article describing an SQL injection was published in 1998 in a FRAC magazine. This year is 2018, so there are about 20 years since we are talking about injection. So happy anniversary. So we've been talking about this one for quite a while. There is definitely something that we don't do quite well. In OWASP Top 10, the first time was listed in 2004 as A6, then progressed up to position number 2 in 2009, and since 2010 is pole position. So going back to the bare definition of what is injection. The injection is when you have some user-supplied input that is then combined with some type of a syntax and becomes a one string, and that one string is sent to a parser. So if you combine the user-supply input with the SQL command like we saw previously, and that one string is sent to the SQL parser, the SQL parser cannot differentiate, and the user input ends up executed as part of the command. That's when you have SQL injection. If the user supply input is combined with HTML and then parsed through the HTML browser, HTML parser, which is the normal browser, that's when you end up with cross-site scripting. It starts executing the code. So that's the bottom line of the definition. When it comes to the controls, that's what you are interested in. You have controls on the input, the parser, depending of the type of vulnerability, and on the output. So depending of the type of flaw that we try to prevent, then we have for SQL injection, primary defense is parameterized. For XXS and XML injection, the primary defense is encode the output. As a defense in layer, always use the validation of the input. But it's worth noting that the primary defense is the parameterization or encoding the output. The input validation is a defense in depth. Next, there are some areas where the parameterization does not work. For example, in the case of SQL, you have locations where you cannot parameterize. These are table, schema, order by. How many of you have had to use dynamic data into order by columns? Yeah, the order by is probably one of the most common ones where you have users coming from the interface, user interface, because the users want click to order the tables by. So in that case, when you can't use the primary defense, what you need to focus on is to reduce your attack surface. When it says validation, then it's to have a minimal attack surface. The best one is to have a list of values. Here I put column 1, column 2. When you actually code, it's better to have an array because you have the key value, because you have the mapping, and then what should be the value for that key. And especially if it comes from the user interface, you don't disclose the name of your column to the end users. If that's not possible, then the next one is a regular expression. Now, some teams, when they design their databases, I know that there are some teams out there that have coding standards. And when they design the databases, they actually decide, I'm going to have this database group of this prefix of tables and then this. It makes also sense when you look at that database. So for that scenario, you can use the prefix in your regular expression and to have a limit as well. So again, we don't have a list, but we have a very small selection, a very reduced attack surface because we allow only certain characters. And it has a limit. The string has also a limit. It's important to bear in mind that you shouldn't allow SQL meta characters into this list, like single quote. So it should be a very limited selection of white listed characters. So that's the other option. If you not, this doesn't work. Yeah, everything that it goes like this, you just increase the number of options, and it's more difficult to defend. That's the entire problem. Great. So this was about the injection. The next one is authentication or broken authentication. And in this case, what we are looking is to exploit the weaknesses in authentication and session management. When it comes to authentication, the best practices are the secure password storage. In PHP, we have, which is one of the best functions, that PHP hash. Sorry, password hash. Which in the recent versions doesn't have the salt, which is awesome, because otherwise people will come out with a random from 1,000 to 9,000, which is great. Also, applications should start looking into implementing using the multi-factor authentication. So the multi-factor is when the users must use a combination of something they know, like a PIN or a password, something they own, like a phone or a key, and something they are, biometrics. So any combinations of these. For applications that contain user data that can trace back to real people, email, pictures, those should have in place second two-factor authentication. Ideally, that was the recommended. And then for more critical applications that can lead to financial losses, those should have two-factor authentication plus hardware token, something that you own. So you increase the number of factors depending of how critical is that application for the business. Great. Another thing is that any sensitive data must be transferred over HTTPS. When designing the authentication, should have in place error messages that do not disclose information about the users, like, sorry, your password is wrong. That's not something that you should do. And also mechanisms to prevent brute force attacks. So this is part of the authentication. Now, after somebody has successfully authenticated, you like to preserve the user's authenticated state. And for that one, what's usually used in applications is the session management, where there are two parts on the server side. You would generate a session. You would store the user data and then generate the session identifier, which must have a unique ID and a very long and must be also as well long and random. So that's for the session ID, a high randomness. Yeah, like we discussed previously, if you end up with two session IDs, then you will end up two sessions ID for two different users, lots of problems from there. Also, it's important that every time the user authenticates and re-authenticates must generate a new session ID. And to have in place, the application to have in place a timeout when it becomes idle, or a maximum absolute lifetime. These two should be correlated with the nature of the data stored in the application. The more critical, valuable the asset, the data in that application, the less the value for this. So you require the users to re-authenticate more often for a higher value data asset application. When it comes on the client side, usually the session identifiers are stored in browser cookies, and when it comes to the domain, it should be defined to a set of minimal paths and domains. It should expire immediately after the session has expired, it has been destroyed. The secure flag helps to ensure that the cookie is transferred only over TLS channel or HTTPS, and the same site equals strict for modern browsers ensures that you do not allow cross origin requests, protects against CSRF. The next item is the sensitive data exposure. Bottom line is protecting data. In transit is HTTPS, and in conjunction with strict transport security header. How many of you are using the strict transport security header? Few. Could be improved because it's more. The data at risk. Does any of you actually require to encrypt data at rest? Database credentials. Okay, this one is the best cryptographic algorithm out there is still for AES, is still AES, but an important part should be also given to the key management, the key that is used to encrypt and decrypt. And these keys must be, they are secret and must be protected from unauthorized access. And also it's good to have in play in application, build your, the feature to rotate the keys. That's another thing that you should take into account. Like I said, the keys are secrets. Nobody should know about them, should access them easily. They definitely should not be stored in the source code. They ideally you'd have a separation between developers and operations, so the operations will have their own process to manage these keys, and then when they generate them, then they will store them into, the best option is an HSM, hardware security module. Amazon has some of those. If you don't have, then you can come up with something that simulates that one, but it's a lot of effort. So try to find one of those stores that are already out there. The next one is XXC, and this is the new entry which was supported by data. In average, from the data that was submitted by the vendors to the OWASP, the average number of applications was about 8%. An interesting number was from the bug crowd data, because they had about 15%, 15.9% of the applications containing this. So the bug crowd are the bug bounties, so people that actually do and exploit, and then they get money for it. While some of the other vendors are static tool analyses, like Veracode, dynamic tool analysis, pen testers. But the background is mainly white hatters. And this XXC, how many of you have heard about this before the OWASP Top 10? So there are only few. So that was my experience, because I was in consultation, and they were like, we have this, this kind of complaints about this. And it was like, okay, let's explain. Have you ever heard about it? No. So this is very easy to exploit. Okay, it might be average to discover, but not that much, because all you have to do is to upload an XML. And then once you upload the XML, it has to be formatted in a certain manner. So it's pretty easy to exploit. As a result, it was a very, and it can do damage, serious damage. So it is one of the highest paying vulnerabilities. Google was paying a minimum of $10,000 if you found bugs in production, on production servers. Facebook has rewarded $6,500, and there are people that were doing only this. And some people have earned $250K only doing XXC. That's all. So when it was this added, one of the questions was, why was this added to the new OWASP Top 10 and the previous one on unvalidated redirects was removed? And going back to the data, they are similar in terms of the average. But the difference was the fact that the XXC had an increasing trend in the last year, while the unvalidated redirects and forwards was decreasing. So people were learning a little bit more about them. They were validating. So yeah, that was one factor. The other factor was the risk, the exploitability and impact. So in terms of impact, the XXC has a bigger impact on the application because you need only that point, while the redirect was a little bit more difficult to exploit and to produce the same, and produce a less impact. So a combination of data trends increasing for XXC and higher exploitability rank brought this one into the OWASP Top 10 and also brought it on this position. Now, another interesting question that was, why is this on its own and is not as part of A1 injection? And this is a very interesting question because there are many people out there, including security professionals, that consider it as part of the injection. In fact, if you look at the release candidate 1 of the OWASP Top 10, actually the CWE 611 was ranked under A1 injection, was listed there. So if we go back to the definition of the injection means you have user-supplied input that you combine it with some syntax and then you send it through the parser. This vulnerability is when you have a perfectly valid XML document. So this is perfectly legal, valid. The weakness is in the parser. So the vulnerability is when you parse this syntactically legal, syntactically correct document through a weak parser that allows access to various resources that it shouldn't be, like, for example, etc password. That's when the exploitability, when the flow is exploited. So the vulnerability is in exploiting the weaknesses in the HTML in the parser. As a result, the correction is you harden your parser. For PHP, it's one line, so it's easy. You should see the code for Java. So this is what it is. Another thing is you actually need XML because XML is quite complicated and the complexity introduces more security issues. If you don't need it, then you can use other formats. So that's the first question. Do you actually need to use it? If you don't, if you actually must use it, then harden the parser, the XML parser. So that's how you deal with this one. The next one is the broken access control at number 5. And as you can see, this was what there isn't much change here. What they did, they actually merged the two ones, the missing function level access control, which has a very long name, and put everything into a more, something that will speak to more people, like broken access control. Here, this everyone can understand what it is. Well, I didn't understand what that one was. So not many things here. The next one is security misconfigurations. So this is what we are talking a little bit earlier. You develop in your development environment, it goes in production, and then you have the database access or whatever, or the permissions. One way to do this one is to develop in your development environment using the least privilege principle, which means that you don't develop as a root, you develop with the same permissions like in the production. And the same for the database. When you design the databases, you should use a similar user like for production, rather to end up with tables that, or parts of the functionality that do more than they should. And sometimes you end up like the most common situation, my code works on my machine and doesn't work in the production. That's a common one. But there are more issues about that one. The next one is A7 or cross-site scripting. And this now is on position 7. And I heard an interesting comment that, oh, we don't have that much cross-site scripting. We sort it out. So that's why it moved on number 7, which is not quite true, because if you remember, at the beginning of the talk, I said one of the changes was the order of the items listed in the new OWASP Top 10. And the order now take into account the likelihood and exploitability. Another thing that was different is that previously, so the OWASP gathers data from a vendor. So let's say you have an application, and that application has 1,000 cross-site scripting. So that was counted in the previous version 1,000. And another application had 1 cross-site scripting, and that was, the total number is 1,001. The difference is that what the guys did, and this was Brian Glass, the actual guy that looked into data to make more sense of it, it was like a pen tester, a scanner, an automatic scanner will find thousands. Easy. It's very easy to detect by the scanners. They will find thousands. A pen tester will find 1 more, and that's it, because they get bored. Then, so now, instead of actually counting all of those, would be 10,000, 1 application, 1, 2 applications. So that's another change. So they count the number of applications rather than the actual number of flows. So it's not that it's less of it, because there is plenty of it out there. There is a lot of it. In fact, we're looking into the raw data without the risk and exploitability. And this is the second most prevalent after the security. 24% of applications have this one, 25. So bottom line is 1 in 5 applications have cross-site scripting from the vendor data that was submitted. So we are still talking a high number. It's just on position 7, because the risk was taken into account, the likelihood and the impact. Great. The next one at number 8 is insecure deserialization. This was included in the OWASP Top 10 based on the survey. So the other security professionals said this is a good one. In particular, in Java, Java is plagued with insecure deserialization because they have it is possible if you combine deserialized with some execute, then you end up executing code. And also those libraries that are vulnerable, they are core libraries for a lot of other frameworks. So there is a big problem in Java. In PHP, I don't think there is that much. It's just don't use unserialized. Don't. So that's the simple don't. Because you have, if you think, then you'll find other ways to achieve the same thing of transferring data from A to B. So yeah, there is not much data. If you look into the data from the vendors, there isn't much apart from the Java. That is quite a bit. The next one is using components with known vulnerabilities. And today, everybody is kind of bringing libraries together and then stitch them together and come up with a new cool application in 5 minutes. which is good because it saves the time, and it's good to use libraries, because especially security libraries, because they have been developed by people that have worked on that and put their mind on it. However, this one still has the problem with this one is you end up using components, open source components that are known for everybody. And if you don't maintain them, upgrade them, then once the vulnerabilities are out there on the internet and everyone knows about them, and they can automate them, and that's why it is one of the most financially rewarding exploits, because the hackers will look onto the database of exploits, then will do automate, and they will just try. The problem with this one is old code, to put it simply. A study from Synopsys showed that 45% of third-party components are over 4 years old. And bottom line, the prevention for this is to upgrade it. And from a development point is you have to pay your technical debt. That's what it is. There's no security magic in this one. It's just pay the technical debt. So if we are to recap a few practices, when you select your components that you decide to use them in your software, use those from trusted sources, from people that know what they are doing, and look how often they are updated. If they haven't touched them for 2 years, don't use them. So they should keep up with what's latest in security, because in security is always this cat and mouse chase, and they should upgrade their flows with the discovery of new attack vectors. Once you bring them, you should encapsulate them, and to use your language, use clean code, or even better, use the recommendation from Robert C. Martin's book, Clean Code, on how to encapsulate these third-party components, to encapsulate it in such a manner that you expose into your software only the functionality that you need, and you hide unwanted behavior. In this way, you also know what exactly from the entire package, what exactly is your software using. And if there are vulnerabilities reported, then you know if you are affected or not. It's much easier. You can get a better control. And if you know, then you are more comfortable. And also, if you have unit tests for that one, then you are more comfortable to upgrade them. Most developers don't upgrade them because it has been done by the previous developer that has moved to a better page, and now they haven't got a clue of what they need to do to upgrade them. And if they upgrade them, there are no unit tests in place, and everybody is afraid of actually touching those because they know that they will break it. And another one is the verify those often. You can have automated tools. For the PHP is the security checker from Sensio Labs, which works with composers, and for JavaScript other ones. So those can be plugged into your Jenkins or other integration tools, and then automatically run after whatever trigger you want to put. And the next one is insufficient logging and monitoring. Now, this is an interesting one. When they decided to add this one, their purpose, or what they thought about, was like, if I, as a white hatter, can get into the application, then it means that there is something wrong because you can't detect me. And that's the entire purpose of this one. You should have in place ways that can trigger and then can detect intruders that try to get into your application. So this is the entire purpose of introducing this for awareness. The most problem is that you do not have common formats, and because you don't have common formats, it means that the ops team can't put them through software to process them. And because they can't be put through automated processing, then every login that you have in there can't be, or alerts do not reach in time. So that's one of the problems. Even the large companies, they detect intrusions months after the hackers have already been there. So now at this point, you might think of what has this one to do with me? Going back to the development, you can actually, there are 6 types of detection points that are considered good identifiers. And these are the authorization failures, authentication, client-side validation bypasses, whitelist input validation, obvious code injection attacks, like for example, you would enter an SQL injection string or a standard cross-site scripting injection string, or a high rate function. So if somebody tries the password about 10,000 times, then there is something wrong there. So using these are taken from the OWASP App Sensor project. Then using these major detection points, then you can actually decide to implement these in your software. So if there is, for example, in the case of request exceptions, if your application expects to receive data by post, but you get it instead via GET, it means that something has played with that request and intentionally has changed it from post to GET. That should be logged in a way. Again, if an extra URL or form parameter is sent, for example, debug equal 1, then that's another indication that somebody has intentionally played through that request. So they have intercepted what the website sent using a device like a burp or even a Firefox tamper data, and then they change it and they send it. That should be logged as well. Authentication, when you have your application expects username and password, but receives only username because the password is removed to see how the application behaves. Again, that's another example where you should have an action and log it. Have a verification in place and log it when it doesn't follow the verification. And another one is input validation. So when your server-side validation fails, despite the fact that you have a client-side validation. A very classic example is you have a form on the client side. In the form, you have a maximum length of 50 characters. What you get on the server side is 100 characters. Definitely somebody has tampered with that data in between. So you should have that one checked. If there is an exception, log it. So I would say that, and another one, radio buttons, non-editable fields, input, checkout, basket, price, hidden prices. I mean, you can purchase for £1. How amazing is that one? Or 1p, even better. Those are as well, yeah. It happens because you don't think, and yeah, somebody would use it, but yeah. So if we are to recap, the OWASP Top 10 list, this list, is an awareness document. And it's dedicated to the testers because it helps them to identify what's the state of security. You should read it once, be aware of it, be aware that there are lots of bad things that can happen. But instead, you should focus on security controls. And when you use them, to use them consistently. So as a result, in the case of application, every time you receive data from input, including from the database, because nobody validates the database because it's trusted. My database is an Oracle, blah, 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 and it's trusted. No, it's not, because it can be tampered. You don't know who can access the database, like hackers, not necessarily the ops people. So once you get the data and you validate it, anything that doesn't match your expectation and is not the right format, the expected format, you should log it to deal with this logging and monitoring. So you should put these ones, you should ideally have in place the common formats that can be automated, so it's easier for everyone to see the alerts if something like this happens. Any output should be encoded. If you store your data in the database, parameterize the queries, or if you ever use OS command injection, you should not use. I don't see why you should ever have the need to access an operating system command if you do parameterize it anyway. If you use XML, harden the XML parser. And if you encrypt the data, then secure the keys into a key management solution. There are more than this, but hey. So the OWASP Top 10, it can't help you out to have in place a security program. To actually implement security as part of the SDLC, you should try with using, you should start using OWASP ASVS for requirements and verification. How many of you have heard of OWASP ASVS? No. Okay, few. Okay, so this is a huge document. It is on 3 different levels, depending of the type of the application. It has 3 levels. Basic one, if you care for your application that it doesn't, if you don't care that your application is going to be breached, fine, level 2. If you care for your application that is going to be breached and there are going to be financial consequences and people are going to be left without jobs, then that's level 3. And for each of those levels has more level of detail about the verification that should be in place. Can be used for unit tests. You can, for functional tests. You can combine it with Selenium and Zap and automate them. So that's one. For security controls, you can have a look at the OWASP proactive controls. Recently has been launched the version 3, and when I say recently, it was like Monday. And the cheat sheets are the best one for a very specific thing. So if you want to have a look at the XXC, there is an XXC prevention cheat sheet, and it's very good. So you just look at that one, that's fine. And then the other thing is, it's important to verify often and early. So as early in the development, code review is the earliest, apart from the fact that you have an IDE with a plugin to a scanner. That's the earliest that I can think of. But I'm not aware of that one existing in PHP yet. But the next one is the code review. Then the next one is hooks when committing code in the repository, either pre-commit or post-commit, and so on. And like I said, the OWASP Top 10 is just an awareness, just a 10 items only to make it easy for everybody. But if you want to really have fun, have a look at this. So this is the CWE structure, is nicely categorized, categories, injection, input. So you have lots of things here, lots of fun. The link is so you can have command injection, cross-site scripting, XML, everything if you fancy it. The link is on the slide, so you can have fun with it if you fancy. Yeah. And on this note, I'll leave it here. Thank you very much for having me tonight.
We've got 2 minutes.
Yes.
Am I allowed?
Yeah, you go.
Oh, I was scratching my head.
Am I allowed 2 questions? One's short,
Yeah.
one's long. So we pay for external pen testing, but we don't do it internally. You mentioned that earlier. Is that the best tool for sort of testing your own infrastructure without having to pay somebody externally to test it for you?
Infrastructure.
So to test your own application.
Application. No, I was referring to, first of all, you need to have some functional tests. You can do those in Selenium. Then you can automate it with OWASP Zap.
And the second question is, much earlier on you mentioned in multi-factor authentication, don't use SMS.
Yes.
Why is that?
Okay. When you are, so the problem is with the weaknesses in the communication, mobile communication system, which stands for SS7 or Signaling System 7. That is an old technology, has been created a long time ago for fixed phones, which means that it's based on trust. If you call from phone A to phone B, the phone B doesn't do any checks, assume that it's phone A. So the weakness is in the fact that there is no authentication. When you're sending SMS-based second factor authentication, what you end up doing is that you send the second factor for authenticated through a non-authenticated system, mobile communication system. What can possibly go wrong? The example is like, depending on the value of the asset, the attackers will put the effort to actually take over. And this happened last year. The targets were German banks, the ones that were using a mobile transaction authentication number. And yeah, the hacker had devised a two-stage attack, where in the first stage, they had a campaign of spamming, phishing, taking the users to fake bank websites to gather bank accounts, numbers, username, passwords, phone numbers. The second one was call intercepting and forwarding the calls to the attacker's phone to get the mobile authentication number. So in this way, they were able to initiate transfers, intercept the calls with the transaction approval, and then move the money. So yeah, it's not recommended. NIST, which stands for National Institute of Science of Technology, prepares to ban it because it can be taken.
It's also just really unreliable.
And we've got a thank you ever so much. Thanks both our speakers.